Hello, this is Rex and this is project 2.6.2, real-time clock prototype. So the circuit is split into two parts, the RTC breakout board, which is powered by the DS1307, and the rest of the circuit, which includes the 80tiny85, which drives these shift registers, which in turn drive these displays, and the grounds are controlled by these four PNP transistors, and all the data of the clock is fed from the RTC breakout board. So this breakout board, the real-time clock, essentially comprises of the DS1307 chip and the source of how it keeps its time, which is the crystal, precisely a 32.768 kilohertz crystal. And it also has a 3-volt battery, which keeps the clock powered even when power goes out. So for example, if I do unplug this, it still returns to the same state, which is 11:47, and it doesn't resets to some random time. And this also leads us perfectly to this display. As you can see, it's using persistence of vision. So that basically makes it dimmer along with all the extra resistors that we've added to the display. And since this clock is designed to be used in a dark environment, this is exactly what it needs. So this is the final version of the RTC prototype. So as you can see, it's fit inside a 3D printed case with a custom PCB inside. And basically, with the tinted acrylic on it as well, it makes it even darker than this display could be. It's just that the light is shining directly on the display, which makes the PCB version seem like actually brighter than it actually is. And as you can see, similarly, it also uses persistence of vision. So let's just quickly dive into the code. So as we can see here, this is the TinyWireM library and allows I2C transfer of data. That's the library that allows it. And here we have all of their variables. This defines the DS1307 address in the I2C bus, and all of the rest of these are like defining the pins for the AT-tiny, and obviously these are the hertz. And this pin specifically is defining the pin on the AT-tiny that would make the LED one specific dot turn on whenever the time is PM. And then here we have all the segments. It's in an array, so we can call on it whenever we want. And basically, like 0 will be displayed like this, incomplete analog, like an incomplete machine level code. And then moving on, we have the setup, which really just makes all of the pins on the AT-tiny set the output, like the ones that are necessary, obviously, and we begin the transfer of data between the I2C and the I2C bus. And during the void loop, we just loop the getting the time from the RTC breakout board and also showing the time on the LED display as a high level description. So first of all, obviously we do have to set the time and date. So as you can see here, this basically scans the time from your computer and it inputs it into the RTC breakout board. And it uses the I2C bus to do this. So like the AT-tiny scans from your computer and then it transfers it over using the I2C bus transmission. And then moving on, we have the get time date, which is ran in the loop. So using the I2C bus again, we're getting time from it, and also this is also the code where it gets to decide whether it is AM or PM, so whether the LED shines or not, using this bit of code that I added right here. And here's the code that changes it from 24 hours to a 12-hour clock. And then finally for showtime, we have basically the AT-tiny85 outputting all of these data to the shift registers, and then each of the shift registers would then do its job and output its output like its data into the LED, which would in turn turn on the LED display and would get the time. And this is basically the square wave function. So it should make the dot turn on and off once per second. And these are just some basic utility conversion functions.